And I'm going to be talking about treating neurodegenerative diseases with low doses of ionizing radiation. Before I talk about Alzheimer, I want to talk about a lot of other sicknesses, illnesses that were treated from 1896 until 1960s. X-rays were discovered in 1895 by Röntgen, and radioactivity was discovered in 1896 by Becquerel. Right off the bat, these medical practitioners started to use X-rays and radioactivity for treating many illnesses. They treated cancer, they put it into remission. Many cases, they treated, eliminated metastases. They accelerated healing of many wounds with low doses of radiation. They stopped infections, and we talked a bit about infections earlier, the earlier speaker. Low doses of radiation can stop infections. They boost your protection systems, your immune system, and they cure the diseases. And most of the cases are cured. And so you have gas gangrene, boils, sinus infections, inner ear, pneumonia. They also treated arthritis and other inflammatory conditions. They treated swollen lymph glands, and asthma. The interesting thing about treating asthma is that a lot of children have asthma, and it's remarkable the doses that were given to small children to treat and cure asthma. Not everyone was cured, but more than half were cured, and the doses were rather high. Now, normally everybody tells you that children are so vulnerable, are so delicate, you have to avoid cancer, the risks are very high, but really, the evidence shows that children can tolerate quite a lot of radiation, including our previous speaker. Now, what I'm going to talk about today is treating Alzheimer's dementia and Parkinson disease. In all of these studies that I've looked at, where they used low dose of radiation for beneficial treatments, there's no mention of increased risk of cancer mortality. So this is all a myth. And they created that in the 1940s to scare people. And in 1956, the National Academy of Sciences publicized that any exposure all the way down to zero, using a linear no-threshold model to predict the risk of radiation-induced cancer. This is a model, dose-response model. You can see it's an inverted J-curve. Basically, when you increase radiation dose or dose rate from background, there's a level before you see radiation-induced effects. That's the first threshold. Then as you increase the exposures, you see an optimum beneficial effects. Beyond that, if you increase the dose higher, the beneficial effect decreases, and you see a threshold at which the effect is similar to an unexposed person. You could call them the control group. They get natural radiation background. If you go beyond that, increase the dose beyond that, you have radiation-induced harmful effects. So when people are using low doses of radiation, the objective is to keep the exposure in the optimum range. Now, I've drawn in here the linear no-threshold model, the red line, and this is the myth, the model that was created to create this scare of radiation by recommending that you use this straight line approach straight line model to determine the health effects, and it goes all the way down to 0. So this is where the scare comes in, because any exposure to radiation will cause a risk of increased cancer. So how did this linear no threshold model happen? Well, in 1927, a geneticist, Hermann Muller, he was trying to improve, he was a eugenicist too, and he was trying to improve the characteristics, the speed up evolution of various species, organisms. And he discovered, he heard from other people as well, that X-rays will induce mutations. And so he applied not just X-rays, but high doses of X-rays at a very high dose rate. And when the dose or the dose rate are both very high, the mutation frequency is roughly proportional to radiation dose. Now, one of the other scientists who came later repeated the experiment, and he decided they would use a low dose rate. It's not really that low, but the dose rate he used was 2 Roentgen per day for 21 days, total exposure of 53 rad, and he saw a threshold, which meant that the exposed flies had the same mutation frequency as the unexposed flies. And so this was evidence that there was a threshold. It wasn't increased, the mutation frequency. Now, Hermann Muller, when he received an award for discovery of radiation-induced mutations, he ignored the evidence of the threshold, and he proclaimed, there's no escape from the conclusion that there's no threshold. And following that, the National Academy of Sciences, this was after the war with the use of nuclear weapons in Hiroshima and Nagasaki. There was a lot of scientists who wanted to stop nuclear weapons development, testing, and proliferation. And so there was a politically motivated movement to create a scare. And what better scare than cancer and mutations? So the National Academy of Sciences Biological Effects of Atomic Radiation Committee recommended in 1956 the linear no threshold model to assess the genetic mutation risk. And today, this is 60 years later, 62 years later, all the regulators in the world still use this linear model to assess the risk of cancer, but they have no data, no dose data to support this linear no threshold scare. And the evidence that many people have presented for the last 100 years, they ignore that. They ignore all the evidence of beneficial effects. Now, this is what happened to the tolerance dose. Early people who were using radiation, the radiologists, from 1924, well, actually from the discovery in 1890s, were using radiation extensively in treating all these diseases that I was talking about. So they discovered after a number of years that there was a threshold dose rate that the radiologists would not suffer any adverse effects. They took 1/10 of the erythema dose. This is the radiation dose that you put your hand in an X-ray beam and it turns red from the X-rays. And that's 600 rem, 600 Roentgen. And they took 1/10 of that, and then they put another factor of safety, and they said, okay, that's the limit per month. And that works out to 70 rem per year. So that was the safe threshold, the safe tolerance dose rate for radiologists. That's 1924. And then people started to get nervous about all those studies they were doing about radiation effects on various fruit flies and other organisms. And so they dropped the tolerance dose rate, the threshold, to 30 rem in 1934. And then they kept ratcheting down, especially after the recommendation came from the National Academy of Sciences. And so what happens is these radiation protection people dropped the tolerance dose rate, the threshold, the radiation limits, by a factor of 70. And then they introduced a different level, which is 10 times lower for the public. And all of this is ratcheting down of thresholds, creating a scare when it was perfectly acceptable back then and even today to have a threshold dose rate of 70 rem per year, annual exposure. So, is it safe to be exposed to low-level radiation? Well, you can go to two different places for the answer to that. If you go to the radiation protection people, whose job it is to protect everyone, and who don't have any work unless they are protecting us, they will tell you that there's a higher risk of cancer. But if you go out in the real world, who do you know that's ever been harmed by low-level radiation? There's just no evidence of that. So this is the issue that we have to deal with. So after that introduction, I want to talk with you about what my experience was with treating Alzheimer's patient who was in a hospice. We gave her 3 CT scans of the brain. This was 3 years ago, July to August 2015. And we saw a quick recovery, like overnight, of appetite and cognition. I asked her, that's my cell phone that took that picture. I asked one of the caregivers to take a photo of us. And there she was. We took one picture of her eating her sandwich. And then I said, Barbara, look at the camera. So she picks up her head and looks at the camera. And we got the second picture. So behind her is her husband. He's got Parkinson's disease. And he had just one scan after he saw the benefit that she was getting, and that stopped all the tremors that he was getting. He was able to sleep at night. So I'm going to tell you more about the story now. First, I want to show you these Alzheimer's disease facts. I'm not going to read them all out to you. You can read them yourself. I get this from a magazine or an online publication called Up to Date. So this is the latest statistics, at least for several years ago. I wrote the article in 2016. You can see it's a very serious problem. So these are the initial facts. And then it goes on. The incidence goes up exponentially with age. It doubles every 5 years after 65. So it's a serious problem for many of us. I'm at 76, and it's something that I think about. And these are the symptoms that come in: memory impairment, executive dysfunction, visuospatial impairments, language and behavioral deficits. And you have difficulty performing learned tasks, such as eating. You have to be fed. And people are linking the brain changes to plaque, amyloid beta, that develops in the brain in older people. The interesting thing is that there's a lot of old people with plaque in their brains that don't have Alzheimer's or Parkinson's or neurodegenerative diseases. So you can't really attribute the relationship, the association. You can't associate the images you see in the CT scan or an MRI of the plaque in the brain to Alzheimer's disease. And this begins really early, the disease, and if you could have a treatment for it, you could stop it at a very early stage, and that would be save a lot of money and a lot of hardship and a lot of suffering for a lot of older people. So how did this discovery happen? This is a story I have to tell you. Back in April the 3rd, 2015, my colleague Eugene Moore, he lives in Midland, Michigan. Everyone there worked at Dow Chemical, I suppose. He called me, he said, my wife's just put her in hospice. She's got Alzheimer's, and she's totally non-responsive. Is there anything we can do to save her life? So I replied, well, a year ago I reviewed this paper, Low-Dose Radiation, Adaptive Response to Control Neurodegenerative Diseases. A colleague of mine, Mohan Das, had written this paper. He's from Philadelphia. And so I talked with him about that. I said, is there any way we can give her low-dose radiation to stimulate her protection systems? So I described the treatment they used for cancer. It's half-body low-dose X-rays, a dose of 15 rad or 150 milligray, twice a week, 5 weeks, 150 rad. The problem was the MD, this is not an accepted treatment in the US, Canada, and most other places. This contradicts the linear no threshold model. But it was used by Dr. Sakamoto in Japan to treat 200 patients with cancer and other diseases. In fact, Dr. Sakamoto treated himself. He had colon cancer. He's still fine now after, this colon cancer was in the mid-90s. So it works, and it works well as a treatment for cancer. The problem was the MD could not prescribe that, so he said, I can prescribe CT scans of the brain. So he says, well, try it. There's nothing else we can do. Now, we told him it's not covered by medical insurance because for a person advanced in Alzheimer's disease, medical insurance will not cover diagnostic imaging. So that treatment, that exposure would normally cost $4,000. But if you're not reading the image, you don't have a specialist reading it, the actual cost that you pay would be $75. So the husband self-paid $75 to get the CT scan for his wife. So the first day after the scan was given on July 23rd. The next day, the caregiver reports an enormous change. Says the patient's eating, she's taking her medicine, she's talking, I can understand what she's saying, she wants to move. And so I got the phone call the same day, and I said, you won't believe it, it's working well. And I said, well, the problem is it's not going to last very long. You have to repeat the treatment. So we were discussing, I mean, here for treating cancer, they do it twice a week or 3 times a week. And here we are treating the brain. We didn't know what would be appropriate. So the husband, me, and the patient's doctor recommended we do this every 2 weeks. So we did it in August, 2 weeks after July 23rd, and then the end of August. And then we did the 4th time. That was October the 1st. And what happened there, we got a setback after the 4th treatment. We had no idea how much, I mean, this is, never treated anyone like this before with this problem. And so when we saw the setback, I got a phone call the next day, and he says, we overdid it. It's gone back to the way it was. And I said, well, don't worry. People are very resilient. They will recover. Let's just cool it and wait. And sure enough, after a few weeks, everything, the improvement we achieved had come back. And so we reached, it was November the 20th, the hospice decided that this patient wasn't getting sick, she wasn't dying, so they discharged her to a mental care home. So she got put in a mental care home. She was getting physiotherapy, she was doing exercise with the other people in the care home. She saw them moving according to the instruction of the exercise person, and she decided, and she was repeating what the others were doing. And the husband was taking her in the car, in his van. He was driving through the country. She was sitting beside him, and he took out the wheelchair, and she climbed out of the seat, got in, and so he was having a life again with his wife. The other thing that was interesting was her friends were coming to the clinic, and up to before then she was totally non-responsive. She was sitting there like a vegetable. They were trying to feed her, and what happened after this treatment was the lady was talking, she was remembering things, she remembered a few names, and people were phoning the husband, Eugene, calling him, telling him on his voicemail, actually, he heard the recordings of how marvelous, how remarkable her response was. And there were email messages he was receiving. So it wasn't just the caregiver, it wasn't just him, there were a lot of visitors who were reporting, plus they discharged her from the hospice. So this is what a CT scanner looks like. This is what the images look for a brain image. And so we decided to do ongoing treatments. First, I wrote a case report. I was there when that picture was taken. It was December the 4th. I came home after I saw her, and I decided I had to write a case report on this. And then I recommended, well, even though she had the setback and she recovered, we're still going to have to do booster treatments to keep it working. And the other thing was she had a neuropsychological examination after the treatments, and the doctor had confirmed that there was a significant improvement in the patient's behavior. So I wrote a second update letter a year later, and I was reporting the results of the booster treatments that we were giving, and then I wrote another update letter which reported her deterioration, and in May 2018, her condition deteriorated very suddenly, and she died on the 18th of May. So she lived about 2.5 years longer than what was expected when she was put in the hospice. And I talked with neurologists in Toronto, and they basically told me it's very difficult to predict when a person with Alzheimer's will die. Sometimes they'll sit for years in a bed for 4 or 7 years before they pass on. So very difficult to predict, but their quality of life definitely improved after the treatment. So this is what the case report looked like, published in April 2016. I was the lead author, the husband is the second author, the person who provided the CT scans is Victor Hosfeld, and the patient's doctor who wrote the prescription for the CT scans was David Nadolski. These are the treatments. The first one was July 23rd. She got a double scan there. That wasn't planned. The person, the technician who was delivering the scans, patient moved during the first scan. So since he assumed that we wanted a good image, he repeated the test, the scan, and so she got double dose then. And then 2 weeks later, we gave the other 2 exposures. And then, I don't know why, but it was 42 days. She got the exposure in October the 1st, and that's when the setback occurred. And then they stopped doing any scans at that point. And then it was resumed in February the following year when I recommended that she probably should have boosters because he was noticing that her condition was deteriorating. The problem was we had no idea what frequency, what time interval between the boosters. So he tried different intervals, and I think in 2017 he gave her a double scan. So had no idea. We haven't done a formal test. This was started off as an effort to save a patient's life, and afterwards we were trying to figure out how to keep her alive. So this is the first update letter we wrote a year after the case report, and this is the second update letter. And in this one, I wrote a lot about the treatment her husband got. He had Parkinson's disease, still has. He was taking 6 pills a day of carbidopa, levodopa, and he was getting continuous tremors when he went to bed. He sat and lied in bed the whole night, and his body was trembling uncontrollably, and he couldn't sleep. And this was day after day, so he was kind of in a daze during the day. But after his wife's improvement, he requested a CT scan. So he got it on October the 6th, and then he went to bed the same day, and the tremors stopped, totally stopped. So he's cut back on the medication he was taking from 6 pills a day to 2.2 to 3 pills a day. And then he waited, and he waited till his disease regressed to roughly what it had been before, and he had a neuropsychological exam in June of 2016. Then he started to do scans every 4 to 6 weeks to control his Parkinson's disease. And in February 2017, he stopped taking pills altogether. And he found that after each CT scan he got, the tremors would decrease to not noticeable. And then when they started coming back, he got another scan. So he was basically going to the doctor whenever the tremors recurred and asked for a CT scan to stimulate his protection systems and stop the tremors. So that's how he was controlling his disease. And that's how he's still doing it. So this is the doses he got. First, as I mentioned, October the 6th, 1 scan. Then he waited about 6 months until the disease deteriorated. He got himself a neuropsychological examination. Then he started taking treatments at different intervals to try and optimize what was the right period of time. And then he got another exam, a neuropsychological exam afterwards, which reported a big improvement. Then he had his eyes tested, and his vision improved. So he used to wear glasses, and then he found that after the treatment for a year or two, that he could read at a distance of 18 inches. He had 20/20 vision, and so he took away his glasses, didn't wear them. He also had a hearing test, and he found that at 6,000 hertz, there was an 18 decibel improvement in his hearing. And the neuropsychological exam was earlier this year, February the 15th, and it shows a big improvement. So this is his neuropsychological exam. There's 6 pages of, it's confidential, so I just show you the first part of it. But so basically with his wife, he was trying to save her life. With him, he's doing a study on himself, trying to determine what the optimum treatment should be for his disease to control it. No, it wasn't just these 2 patients. I mean, you call them anecdotes. What's so big about having a single patient get a recovery. Well, there's another patient. This is interesting how it happened. When I first wrote the case report, I submitted dose response journal, and Calabrese is the editor. He talks to his wife Mary at supper time. He says, I got a paper here from Jerry, and this is a treatment for Alzheimer's disease. So Mary says, my girlfriend's husband has got Alzheimer's. I want to do something about that. It's early stage. So the two of them, I go to visit them in January 2016. They end up asking their neurologist to CT scans for the husband. This is the second Alzheimer's patient. So he improves after the first scan, and then the doctor doesn't do the repeated treatments 2 weeks apart. What she does is she waits 3 or 4 months and then does it again. And so every time they did the scan, there was an improvement, but there wasn't, they weren't maintaining an improved condition. So he kept deteriorating. It's like a sawtooth going downhill. And the way we saw the improvements, not only did he feel good, this fellow played the clarinet. He was in a jazz combo. And after he got his treatment, the combo, the other people who were playing with him noticed a big improvement in his playing of the clarinet. He was improvising, he was playing well, and then weeks later it would deteriorate. So I have a diary that his wife wrote of the history of his treatments. And the doctor gave him various tests before and after each treatment. And so I've got evidence like that. Now, we got to the point of May last year when she said no more treatments until I receive results from Toronto clinical study. I was in the process of starting a pilot study in Toronto, and the doctor was getting very nervous about treating this patient with a treatment that's not accepted. So she stopped treating him, and the husband was telling his wife that if anyone asks what I want for my birthday, I want a CT scanner. Now we have a third patient. So there's now 3 patients with Alzheimer's and 1 with Parkinson. So that's another anecdote, if you want to call it that. This patient, also in Massachusetts, from Noel, the way it happened is amazing. What's his name? Bill Gates donated $50 million to find a cure for Alzheimer's disease. So he has this website with this part of it called Notes, and everybody's writing in contributions, articles, ideas. So I put in my 3 articles, the case report and the 2 updates, in April. This is this year. And then in June, I get a message, email message from this lady. She owns, or she's the manager of an oral clinic in Noel, Massachusetts. What she did was, she has a neighbor, his name is Bob, lives beside her. He's got Alzheimer's, he's in a health clinic, health care institution. So she brings him into her office, she repositions the machine and the patient, and she gives him a scan of his brain after she read the articles on Bill Gates' website. So pre-scan, he was struggling to walk, mumbling with only a few words that were recognized. Would not eat, no fluid consumption. And then she does the scan, and the next day, he's walking, picking up things in the nursing home floor to clean up. He's still a bit confused, but his words are understandable, clear. He's eating, drinking, and when he's asked. And so she wants to give him more treatments. And I say, well, you better be careful, because what you're doing violates your license, and you could be shut down. You can have penalties. You won't be able to use the machine anymore. So he says, whatever you do, keep it quiet. So I don't know what else she's doing, but she does know I've got a study going. So let me tell you about my study. I was contacting many people in the US and Canada, urging them to repeat the results, the tests that we did in Midland, in Michigan. And none of them would agree to do it. They kept telling me that they're too busy. They recommended we do studies on mice. And I said, look, this is a treatment that's used. It's a procedure that's used for imaging a brain. It's considered safe, and so there's really no risk. But nobody was wanting to do it. They didn't believe it would work. So near my home, there's this place called the Baycrest Health Center, Geriatric Health Sciences in Toronto. They're just celebrating this year their centennial. My grandfather was treated in the forerunner of this clinic in 1945, 55. He was there for a number of years. And so I went there and I started in March, and I kept asking them for an appointment. March, April, May, I got lucky. I met the director on May the 3rd. I showed him what I had, and he agreed that this is important. Now you'll notice one of the reasons I picked the Baycrest is you can see their motto there. Baycrest is where we will win the fight against dementia. So I thought this is the appropriate place to work with. And so they have many Alzheimer's patients, but there's no radiation facilities there. So we set up another meeting, he did, with a colleague of his at the Sunnybrook Hospital. And we had another meeting on May the 19th at Sunnybrook. They have a lot of radiation facilities. It's a veteran affairs type hospital. It's huge. They have a lot of Alzheimer's patients, but the study is being done at the Baycrest. So there's no funding. No one wants to donate money. So when we wrote up the proposal, they asked for a funding source, and we say none. And so what's happening is Baycrest is picking up their own costs in terms of how they're treating their own patients. They're treating them anyways, but where they're going to be doing tests. And the Sunnybrook is picking up their costs, including doing the CT scans. And I've got skin in the game as well. I'm the fellow who's paying for the transportation, these people in wheelchairs, between the two hospitals. So it's $100 to bus them there, $100 to bring them back. 3 patients, $1,800 I'm donating to the hospital. And so they hired a neurologist. They keep him busy on routine work, but he's the principal investigator for our study. So we have 6 investigators. 4 of them are MDs. There's me, and the other one is the statistician. So I wrote up the protocol. These people, it takes them a long time to write these documents. But I have a lot of experience in writing documents, so I sat down with them. I figured out what has to be done, and we put together the protocol, the research application, the patient consent form, and these patients can't really consent, so we have to rewrite it for designated, what do they call it, a substitute decision maker. They're the ones that sign off. They have the power of attorney for these patients. And so there's 6 of us. We've got those. The ethics board, I had to go through all the comments and responses. So I got approval this year on February the 28th. That was provisional approval. I had another problem. This machine that they're using, a CT scanner, the license is for diagnostics, and I'm using it for treatment. So the fellow running the CT scanner said I can't really use it because it violates my license. So I had to contact Health Canada, talk to the right people. I got in writing permission to use the CT scanner for therapy since it's part of an approved study. So with that letter, I got Sunnybrook sign-off on the ethics board on July 13th. That's Friday the 13th is my lucky day. And then the Baycrest full approval on July 17th. So at that point, we were ready to do patient selection, except that the principal investigator went on vacation. And when he came back, we found out we needed a data transfer agreement between the two hospitals, and we couldn't find anyone to sign it in August. So hopefully when I get back from here, we'll be able to start patient selection. And then we have to do the tests. We're doing 3 tests. There's function, cognition, and behavior. The first test is ADF-ACS. Then there's this severe impairment battery. And so all this are legitimate tests that are done for Alzheimer's disease. We're doing everything according to the book. We're doing it with ethics board approval. We're going to publish it in the proper journal. And hopefully this will pave the way for a treatment. Now this is a pilot study, only 3 patients, but if I show good results on these 3 patients, I'm very confident I'm going to get a lot of money to do a proper study in a proper, we got to do a lot of studies. We need to know different patients, different stages, what's treatment, what's the optimum dose, what's the interval between the treatments. There's a lot of factors, information that we need to know before we can do anything with this. So I have our clinical study is now registered on the clinicaltrials.gov. We have a number, identifier number there, and if you put that in, you get, I don't know, it's about 10 pages, including all the references about our registered clinical study for Alzheimer's with low-dose radiation. I'll say a few words about the mechanism, since nobody really knows that well what the mechanism is. My theory is, and I've got a lot of advice from Ludwig Feinendegen and a few other medical doctors on the mechanism. Basically, it's long-term oxidative stress. We have protection systems which are old, and they prevent normally damage and remove, repair. And what's causing the damage in the brain? Well, it's breathing air. The oxygen that we use to react with the glucose in our blood to energize our cells, the same oxygen's damaging biomolecules, and we have protection systems which are dealing with this damage that happens from the day of our first breath until our end. These protection systems are working, but when we get old, these protection systems become less effective, they slow down. So each CT scan releases a burst of reactive oxygen species. We were talking earlier, another speaker, about how radiation breaks up water. 75% of our body is, on the average, is water. And so ionizing radiation causes reactive oxygen species, hydrogen peroxide. And so there's 2 reactions that happen, the swift acting immediate repair and removal of damage due to the CT scan. And then hours later, signaling starts to appear as the stress responses that last from days to a lifetime. These are called adaptive protections. And they operate against the damage that's done by the CT scan itself, which is minuscule compared to the natural damage that's caused by breathing oxygen. And so this performance of this adaptive protection defines the dose response curve that I showed you early on. So this is another version of the same story. You have direct interactions, and then you have indirect interactions, which happen because the ionizing produces the free radicals that are stimulating our protection systems. We're upregulating a lot of genes, more than 150 protective genes, and the amount of upregulation, it's different for each individual. Each person has different genetics, so you can't expect every person to get the same benefit. So there are differences, but the differences are small compared to the overall effects. So I'm very, very confident that every patient that gets treated will show a benefit, but I can't quantify which ones will get more and which ones will get less, but they will all benefit. The idea that this radiation would cause damaging genes to be expressed is not credible. So the problem I'm having, of course, is there are a lot of people out there, this fellow David Brenner and others, keep talking about cancer risks from imaging. And he's been publishing for many years, and there's other people as well, other medical doctors publishing. He's actually a PhD. But there's a lot of other doctors publishing information about risks of cancer from CT scans, especially for children, which is fake news. Now here's a study that I had to use in my ethics case. They were asking me again and again, why aren't we causing cancer, brain cancer for these Alzheimer's patients? Well, I say, well, if you believe the LNT model, there's a latency of 20 years. So here we're taking an 80-year-old person and we're giving them a low dose, and if you want to consider a risk of cancer, that's going to come in 20 years. And meanwhile, we get immediate response on beneficial effects for Alzheimer's. But I actually have studies that were done in Canada last year, at least they were published last year, that single CT scans prolong survival and extend cancer latency even later. And these are special mice, TP53 heterozygous. That means there's two chromosomes. You take out P53 in one of them, the mice become cancer prone and sensitive to radiation. And in these deficient mice that are vulnerable, we show that the CT scan prolongs survival and extends latency. So this is for a single scan. And of course, I've got the same paper, a different paper, on multiple CT scans. So these were important references that I used in my ethics case, in my protocol, to justify the treatments, the study that we were doing. So I've got a lot of other material, and I'm probably running out of time. So we'll break off there and answer questions.
Great talk.
Thank you.
I've got a somewhat of a background in radiobiology and a lot of experience on human ethics in research. I think it's called a patient advocate. You might try writing a grant on finding the adverse effects of CT scans for treating Alzheimer's and Parkinson's. Because when that's funded and you find no adverse effects, you've got a winner.
Can you send me a message, an email message, giving me more information on what you're recommending?
And in fact, that's a statistical technique. You set up your study to find something adverse, and then when you don't find it, what's the opposite conclusion? In terms of mechanism, I don't know much about these doses, but you see vascular permeability sometimes increased in radiation exposure. So you may have areas of the brain that, due to vascular poor permeability, are not getting oxygenated. So you might have a temporary effect due to vascular permeability.
Okay. So in your email message, would you also amplify on that point, and I will try and make use of it.
I'll do my best.
Thank you.
Jerry, I
Yes.
think this is an excellent idea, and it follows the IPCC idea on global warming kind of thing, where they've never spent a dime to find out natural variation. They've spent all their money trying to prove global, man-made global warming. And that gets all the money in the world. And what he's suggesting is exactly that. I think we ought to follow that.
Well, a lot of the money is going into radiation protection. I have no money to do our pilot study. Alzheimer's is a very big problem, and I'm hoping that this pilot study will present enough evidence to lead to funding. I should mention that I did contact the Alzheimer's Association in Chicago, and I asked them to do something about this. I said, here's some evidence, and they turned around and said, you write up a proposal, you send it to me with your schedule and cost estimate and who you're going to hire, and we'll look into whether we can approve it and give you funding. Now, I had no idea how to write a proposal, and it's only this past year where I was working with the hospital people that I was able to write an application, a protocol, patient consent form. It's complicated, and we still didn't get any money. So the hospitals, the directors believe that it works, and they put their skin in the game, and I put mine in the game, and we're all hoping that it'll turn out for the best. Yes, Jane.
I understand that you're using a CT scan of the brain because it's available. Do you think that the same protocol, like for total or half body radiation, would work if instead of radiating the brain in a neurologic condition?
Yes, I agree that we don't know that. That's one of the tests I'm going to have to do. We all know about what's called the bystander effect, or the fact that cells communicate. And it's well known that if you can treat one area, the effects spread over the entire body. And you can even have plutonium injected in your lungs, inhaled, and yet it will affect not just the lungs, but the entire body. So I don't know. The way it worked out was the CT scans of the brain were the only thing that the medical doctor, the patient's doctor, could sign, could approve. And he didn't do it as a research study. His concern, as every doctor's concern should be, on how do I help my patient? How do I help a person survive? And so he wrote the the prescription to give her treatment so that she might get better. And we made this discovery that the CT scan of the brain would produce this benefit. Now, CT scanner is a very expensive machine. It's used for imaging, and there's a lot of cost involved in a function that we don't need. We are going to only expose the radiation and not use the image. However, it's a very interesting thing that happened in the hospital with when I was going through the ethics board. The ethics board insists that we change our protocol, that the hospital is going to pay for looking at analyzing the images. And if they detect anything that's interesting, they will report it to the patient or the designated person, designated approver, and they're going to look at anything that they discover from the image. But our objective was just to cause some X-ray stimulation of the protection systems. So it's a long answer to a short question. But as part of the new tests that we will do in further studies, we'll be examining, exposing other areas of the body to see their effect on Alzheimer's disease. Of course, we know that I gave a list of a whole lot of illnesses that are improved or treated properly, well, with low doses of radiation. So we're going to start seeing a lot of other things happening in addition to the Alzheimer's. Probably have to check a lot of things, not just Alzheimer's test.